Hello students and my dear friends, I welcome you all to my channel. This is class number 3 on the chapter Algebraic Expressions, and this video is part of the playlist CBSE Mathematics class 7 following the textbook of author R.S. Aggarwal. Now in this video I will not discuss anything from the class 7, but rather I will try to discuss the concepts on algebraic expressions you have already learned from class 6, just to refresh your already learned concept. I will not discuss, even though I had prepared notes for the concepts from the class 6, that is the addition, subtraction of expressions, evaluating expressions by substitution and simplification of expressions. I thought that following the notes will take a long time and it will make the video much longer. So I thought of solving 10 MCQs that will cover all the concepts that you have learned in class 6, and while solving the problems I will try to discuss the concepts as and when necessary. So let's get started. Okay, so you can see the MCQ test paper, not test but MCQ of 10 questions I have on the left hand side, and on the right hand side I will solve the problems. Okay, so let's start solving the problems, and while solving the problems I will try to discuss the concepts required to solve the problem. So the problem number 1 says that if A, B, C are three algebraic expressions given, and it is asking that then the terms of A plus B plus C are. It's an MCQ, so we have 4 choices for all questions, and only one choice will be correct. So A, B, C are given algebraic expressions. We have to find A plus B plus C, and then we have to say how many terms are there in A plus B plus C. Okay, so basically this is a concept of adding algebraic expressions. So we have A plus B plus C. I will not solve the problem in very details. I will try to be as compact as possible, but I will discuss the concept and the steps. So A plus B plus C is nothing but, if you write 2x cube minus 3x square plus 7x minus 8. So this is the algebraic expression of A. Then plus we have B minus 5x cube plus 2x square minus 4x plus 1, and finally the algebraic expression of C is 3 minus 6x plus 5x square minus x cube. So how do we add algebraic expressions? So we have these 3 algebraic expressions and we have to add them. So the method is that we add the like terms. We add the like terms and we leave behind, and we keep the unlike terms unchanged. So from here, if we group all the like terms together and we leave the unlike terms unchanged. So we can see that all the algebraic expressions has terms where the literal coefficients are x cube and x square and x, and also we have a constant term in all the algebraic expressions. So if we collect the like terms where the literal coefficient, I hope you know what is the literal coefficient of a term. The literal coefficient of a term is everything except the constant part. What is the constant part? Constant part is the numerical coefficient of the term. Like for example 2x cube, the term 2x cube in the first expression, its literal coefficient is x cube and numerical coefficient is 2. Numerical coefficient of a term is also known as coefficient. So its coefficient is 2 and literal coefficient is x cube. So if I group together all the terms having literal coefficient x cube, I have, so I am grouping all the like terms. So 2x cube from the first expression, then minus 5x cube from the second expression, and minus x cube from the third expression. So I have grouped all the like terms where the literal coefficient is x cube. Similarly, I will do for all the like terms where the literal coefficient is x square. So from the first term I get, first expression I get minus 3x square, from the second expression I get plus 2x square, and from the third expression I get plus 5x square. Now I will group together all the like terms where the literal coefficient is x. So from the first term, from the first expression I get 7x, from the second expression I get minus 4x, and from the third expression I get minus 6x. And now only the constant terms are left. So the constant terms from the first expression is minus 8, from the second expression is plus 1, and from the third expression is plus 3. So this way you do the addition of two or more algebraic expressions. Now how do I? So now this thing is nothing but nothing but addition of like terms. Addition of like terms. All these are like terms. 2x cube. I am, for the sake of discussion, I am writing, but it might look very clumsy. Even, but just for the sake of discussion, I am writing over here. The like terms are 2x cube minus 5x cube and minus x cube. I hope this is clear. Similarly for the other like terms. Now if I add the like terms, if I do the addition 2x cube minus 5x cube minus x cube, how do I do that? I will add their coefficient. I will add the coefficient of all the like terms. So this is 2 minus 5 minus 1, and then the literal coefficient of the like term, that is x cube. Similarly, I will do for the other like terms. Over here, for the like terms with for the addition of all the like terms with literal coefficient x square, it will be, I will add their coefficients, that is minus 3 plus 2 plus 5, and I will have the literal coefficient of the like term, that is x square. Similarly, for the like terms with literal coefficient x, it will be 7 minus 4 minus 6 into x, and finally the constant term, just we do the arithmetic expression, minus 8 plus 1 plus 3, which is minus 4. Okay, which is minus 4. Now if we simplify the coefficients, this is for x cube, the coefficient becomes minus 4x cube, and for x square the coefficient becomes 4x square, and for x the coefficient becomes minus 3x, and this is constant minus 4. Now this is the final expression becomes minus 4x cube plus 4x square minus 3x minus 4. Now it is asking that the terms. Now if this is the final expression, then the terms will be minus 4x cube, 4x square minus 3x and minus 4. So this should be the result or the answer. We have to see the correct choice. I think C is the correct choice. C seems to be the correct choice. Yes. So the answer is choice C. While I am solving, you can take a screenshot for your future reference. Okay. Let's solve the problem number 2. Problem number 2 says if A, B and C, A is given an algebraic expression, B and C are given some algebraic expressions, then the product of numerical coefficient of x square and a square in an expression is given, a plus the square bracket inside we have a minus something like that, just like you simplify do. So we have to simplify the given expression, that is a plus square bracket a minus curly brace b minus c minus a. First we have to simplify that and we will get a algebraic expressions. From that algebraic expressions we have to find the numerical coefficient of x square and a square. Now I will discuss what does it mean to find what does it mean by the numerical coefficient of a factor in an algebraic expression. Now let's first so we are given a plus a. So this is a simplification, this is another concept, this is a simplification of some algebraic expressions where we have grouping symbols. The square bracket, curly brace and parentheses are known as grouping symbols. So how do we do this kind of simplifications? We have to first remove the innermost grouping symbol. In this problem, the innermost grouping symbol is this. So we have to evaluate or simplify c minus a. Whatever that algebraic expression is, we have to combine all the like terms and so that we have most simplified algebraic expressions where all the like terms have been added or combined. Then we will remove the next outer grouping symbols, that is the curly brace. So this way we will proceed until all the grouping symbols have been removed. So if I replace this expression by the algebraic expressions, this becomes x square minus a square. Now instead of writing it all the time, for the time being I am writing it a, and I will only write the algebraic expressions which will be required. So first we have to do this c minus a. So I am writing c minus 5x square plus 2a square. Now minus, this is minus of a, Now a, this is another concept. What is a is an algebraic expressions. What does it mean? A is x square minus a square. This is an algebraic expressions. Now what does minus a means? So in c minus a, we know that c minus a, even though c, a, b, c are all algebraic expressions, we know that for number system a minus b is a plus additive inverse of b. So here also the same concept logic will work. This is equal to c plus the additive inverse of a, that is additive inverse of a. Even though a is an algebraic expressions, the concept it works the same way. So now what does additive inverse of a, that is minus a, means? This is nothing but minus of x square minus a square. This is nothing but you just change the sign of all the terms of a. What are the terms of a? What are the terms of a? The terms of a are x square and minus a square terms. Now, so what are the terms of minus a? So by arrow I mean to say what are the terms. The terms of a is x square comma minus a square. The terms of minus a will be, all the terms will change their sign. So for a the terms was x square. So for minus a the term will be minus x square. Similarly for a the term was minus a square. for minus a, the term will be minus of minus a square. I mean, the opposite, it will change the sign, so it will be a square. So we have minus a equals to minus x square plus a square. So this we got minus a equals to minus x square plus a square. So now sorry, what is happening? Okay, so let me mark this as a side note. Now instead of replacing c with the algebraic expressions, let me write c minus a as c plus minus of a. So now this is a plus a minus b minus c plus a, c plus additive inverse of a. Now c we know that minus 5 x square plus 2 a square, and minus a also we know that is minus x square plus a square. So this is a plus. Now once that we have, we are still evaluating the innermost grouping, that is c minus a. Now we have so c minus a, we got the algebraic expression as minus 5x square plus 2a square minus x square plus a square. In this we have to combine the like terms, that is we have to add the like terms, and this, when we add the like terms, minus 5x square minus x square, it becomes minus 6x square, and when we add the like terms 2a square plus 3 plus a square, it becomes 3a square. So and then we have this grouping. So now this is a plus a minus, so now we have so now we can now open the innermost grouping, because it is already simplified and there are no all the like terms has been combined or added. Now we have to open up this innermost symbol, grouping symbol, that is the parenthesis. But before the grouping symbol, we see a negative sign. If there is a negative sign before grouping symbol, we have to change the sign of all the terms inside the grouping symbol. So inside the grouping symbol we have an algebraic expression which is minus 6x square plus 3a square. So when I will remove the parenthesis, but before that I see a negative sign, so I have to change the sign of all the terms inside the grouping symbol. So this will become minus 6x square will become 6x square, and 3a square will become minus 3a square. So we have removed the innermost grouping symbol. We have this. Now we have to put the algebraic expression of b, that is, what is b? b is minus 4x square plus 4a square, and we have this 6x square minus 3a square. Now we have to evaluate the expression inside the next the outermost grouping symbol, that is the curly brace. Now we see here we have some like terms, so we have to combine the like terms. So when we combine the like terms in the algebraic expression inside the curly brace, we see the like terms x minus 4x square plus x square will become, when we add them, the coefficient will add, so it will be minus 2x square. Similarly 4a square minus 4a square and minus 3a square, these two like terms will add and will become plus a square, and we have this curly brace and the square bracket. So now the algebraic expression inside the curly brace has been simplified. Now we have to open it. Now again we see that before the curly brace rooting symbol there is a negative sign. So we have to negate, we have to change all the sign of the terms inside the curly brace. So this becomes minus 2x square minus a square. Now we put again the algebraic expression of a, which is x square minus a square, and we already have minus 2x square minus a square. Now we have to simplify the algebraic expression inside the square bracket, that is combine the like terms, add the like terms, and we see that when we add the like terms x square and minus 2x square, that is minus x square, and when we add the like terms minus a square and minus a square, that is minus 2a square. So this is this. Now again we have to open, this was square bracket, we have to open the square bracket, but before that we have a plus sign, so we can simply open it. This becomes a plus you can say minus x square plus minus 2a square. This is nothing but a minus x square minus 2a square. Now we will replace a with the algebraic expressions, that is x square minus a square, and we have minus x square minus 2a square. Now x square and minus x square cancels out, and this becomes minus 3a square. Then the product of numerical coefficient. Okay, so the expression becomes this. And the question says the product of numerical coefficient of x square and a square in a. Now the simplified algebraic expression is minus 3a square. Now what is the numerical coefficient of x square in minus 3a square? It is 0 because there is no x square in this term, whereas the numerical coefficient of a square in minus 3a square is minus 3. So the answer actually will be the numerical coefficient of x square in minus 3a square is 0 because there is no x square term. So the answer is 0 into minus 3. Minus 3 is the numerical coefficient of a square in the final algebraic expression or term minus 3a square. So this is 0. Now let's suppose these algebraic expressions would have come to, let's say, 3a square minus 2x square. Let's say, suppose. Now what would the answer be? What is the numerical coefficient of, I'm writing in short, NC, numerical, and let's say this be E, an algebraic expression. This is the simplified algebraic expression. Let's suppose that if this was the simplified algebraic expressions, now numerical coefficient of a square in E is 3, and numerical coefficient of x square in E is minus 2. So in that case the answer would have been 3 multiplied by minus 2 equals to minus 6. But for this problem the answer is 0 because the simplified algebraic expression has come out to be minus 3a square and it has no x square. So the question says the product of numerical coefficient of x square and a square. The numerical coefficient of a square is minus 3, but the numerical coefficient of x square in the final simplified algebraic expression is 0. So 0 into minus 3 is 0. So this is about a side note. So the answer is choice C. While I am solving it, you can pause the video and take a screenshot for your reference. Let's do question number 3. Question number 3 says, for constants k1, k2 and k3, if we have there are addition of two algebraic expressions equals to 0, then the value of mod absolute value of k1 plus k2 plus k3 it is asking. It is given that k1, k2 and k3 are constants, they are not variables, even though they are being represented as by letters, but there are some constants. Okay. Now, okay, so it is saying that the sum of these two algebraic expression is 0. Let's first find out what is the sum of the given two algebraic expression. We have to keep in mind that k1 and k2 are constants, they are not variables. I mean, they are constants like 4, 5, 6, but it is some constants represented by letter. Now, okay, and this is k3 x cube plus 4xy plus y3. Okay, now this we know, this is addition of two algebraic expressions. And how do we add two algebraic expressions? We just we add the like terms and leave the unlike terms as it is. Now we can see there are like terms with the literal coefficient x cube, and also like term with the literal coefficient xy, and another like terms with the literal coefficient y cube. So if I combine the like terms with the literal coefficient x cube, I will just add the coefficient, I will get 5 plus k3 and the literal coefficient x cube. Similarly, if I do it for the like term with literal coefficient xy, I will get, it will be minus k1, the coefficient of the coefficient of the term minus k1 xy is minus k1. Similarly, from the second expression, the coefficient of the term 4xy is 4. So we are adding the like terms having the literal coefficient xy. So this is this. Now if we add the like terms with literal coefficient y cube, I get k2 plus 1, because y cube in the last term of the second expression y cube, its numerical coefficient is 1. Y cube. This is given to be 0. Now this implies okay, now if this is 0, now see, the whole algebraic expression is 0. What does it mean? What does it mean? This obviously means that 5 plus all the terms on the left hand side, all the terms has to be 0. This is 0, minus k1 plus 4 xy, this is also has to be 0, and k2 plus 1 y cube, this also has to be 0. Because what does the algebraic expression 0 means? It's a single term and it's a constant term 0. So definitely on the left hand side, all the terms, we see three terms, right? We see three terms where the first term is having literal coefficient x cube, the second term is having literal coefficient xy, and the third term is having literal coefficient y cube. But they all have to be 0. They all have to be 0. Now, when this is 0, if this is 0, this implies the coefficient, the numerical coefficient has to be 0. This has to be 0. This implies k3 is minus 5. Now, if this thing is 0, this implies its numerical coefficient of the term has to be 0, that is minus k1 plus 4 has to be 0. This implies k1 equals to 4. Okay, now if this is 0, if this term is 0, then definitely its numerical coefficient k2 plus 1 has to be 0. This implies k2 equals to minus 1. So we have this result. We found out k1, k2 and k3. Now we have to evaluate, we have to find the mod of k1 plus k2. Mod means this is the mod sign, which means the absolute value of a number, or the numerical value, absolute value or numerical value of a number, that is the number without the sign. That is, the absolute value of minus 4 is 4, the absolute value of 0 is 0, the absolute value of minus 6 is 6, the absolute value of 5 is 5. So now we have k1 is 4, k2 is minus 1 and k3 is minus 5. So we have mod of 4 minus 1 is 5. This is mod of 4 minus 1 minus 5 is minus 2, and mod of minus 2 is 2. So the answer is choice C. Okay, let's see question number 4. Question number 4 says the like terms in, some terms are given, the like terms in are. Okay, so the terms given are x square. So this is the concept of like terms, minus 4 xy square and 2x square y and 3 y square x. Now when are two terms said to be like? When the literal coefficient is same. They have two terms are said to be like terms if they have the same literal coefficient. For this term, I'm in short writing LC for literal coefficient. For this term, the literal coefficient is x square y square. For this term, the literal coefficient is xy square. Xy square. What is the literal coefficient of a term? Everything in the term except the constant part, or except the numerical coefficient, or except the coefficient. So for the first term, the coefficient is 1, and for the second term, the coefficient is minus 4. So everything except minus 4, that is xy square. So for this term, the literal coefficient is xy square. Now for this term, the literal coefficient is x square y, and for this term the literal coefficient is y square x. So where do we see similarity? X square y square is not matching with anything, x square y is not matching with anything, these two are matching, y square x and xy square. So the like terms are 3y square x and minus 4xy square. So these are the like terms. So the correct choice is B. The correct choice is B. Okay, let's do question number 5. The product of literal coefficient of all terms in the expression is, okay, the product of literal coefficient of all terms the expression given is minus 3 xy plus 4 xy square minus 3. So the terms are minus 3xy, 4xy square and minus 3, and it is asking the product of literal coefficient of all terms in the expression. Okay, so we have to find the literal coefficient of all terms. What is the literal coefficient of this first term? Literal coefficient, I mean short writing LC. The literal coefficient is everything except the coefficient or the numerical coefficient. The coefficient or the numerical coefficient of first term is minus 3. So leave that, whatever remaining is its literal coefficient. So xy. For this second term, the literal coefficient is x y square, and for the third term, that is the constant term minus 3, the literal coefficient is 1. The literal coefficient is 1. Okay, so now we have to find the product of this and this. So 1 into xy into xy square. This is x square y cube. So the correct choice is C, x square y cube. Okay, let's do question number 6. So this problem was based on the concept of literal coefficient of a term, and also literal coefficient of a term, and also how do we find the terms of a given expression. What is 6? Question number 6. Question number 6 says we are given two algebraic expressions p equals to ab minus a square and q equals to 5a square minus 2ab. Okay, and it is also saying that let p u comma v equals to value of p when a equals to u and b equals to v. Okay, so it's a kind of substitution problem. It is saying that value of p u comma v is the notation of the value of p when we put substitute a, the value of where we substitute the value u as a, and v, the value v for b. That value, it is being denoted as p u comma v. Similarly, for q u comma v, it is the value of q, that is the value the value of the expression q when you substitute the value u for b and you substitute the value v for a. Okay, these are the notations. Now it is asking then the value of p 2 comma 3 minus q 1 comma 2 is. Okay, so as per whatever the algebraic expression is given and the notation is given, how do we find p 2 comma 3? p 2 comma 3, as per the given description, it is saying the value of p when a equals to 2 and b equals to 3. Okay, so now we have to find the value of p, where we have to substitute a, the value 2 for a and the value 3 for b, and if you do that, the value becomes, if you substitute the value 2 for a and 3 for b in the expression p, it becomes 2 into b is 3 minus a square, that is 2 square. So this is 6 minus 4, this is 2. So we found p 2 comma 3. And what is q 1 comma 2 is, it is saying the value of q when b equals to b equals to u means in this case b equals to 2 and a equals to v means here 1 no sorry where b equals to u. Okay, b equals to u, b equals to u means b will be 1 and a equals to v means v here is 2, so equals to 2. Now, so we have to find the value of the expression q by substituting the value 1 for b and 2 for a. Now, if you substitute the values in the expression q, it becomes 5. 5a is 2 square minus 2a is 2 and b is 1. So, this is 5 into 4 minus 4. This is 20 minus 4 is 16. So, therefore P 2 comma 3 minus Q 1 comma 2 is 2 minus 16, that is minus 14. So, the correct choice is C. Okay. Let's do problem number 7. So, this question was based on evaluating a given expression by substituting some values for the variables in the expression. Just that there was a new kind of a notation that was described, that u comma v is the value of p when a equals to u and b equals to v. This could probably be a little hard to understand, but I'm just trying my best to come up with questions that will make you a little think. The questions are not straightforward, but at the end of the day, the basic concepts will be applied. Question number 7. Okay, 3 algebraic expressions are given, a, b and c. Then the algebraic expression a plus b plus c is a, choices are monomial, binomial, trinomial, and d is none. Okay, so first of all we have to find what is a plus b plus c. So, a plus b plus c equals, if we put the expressions, minus 2x square plus 4x minus 1 plus minus x square minus x plus 2 plus 2x square minus 3x minus 2. Now, we know that when we add algebraic expressions, we just combine, we add the like terms and we leave the unlike terms as it is. So, if I combine the like terms with literal coefficient x square, I get minus 2, we just add the coefficient minus 2, minus 1 plus 2 x square, and if we add the like terms having the literal coefficient x, we get 4 minus 1 minus 3 x, and for the constant terms we have minus 1 plus 2 minus 2. Now, if we further simplify this, we get minus 2 cancels. This is minus 1 x square, this is minus x square, and over here we have 4, 0. So, x is gone, 0 into x, plus this constant is minus 1. So, this becomes minus x square minus 1. So, it is having two terms. The terms are minus x square and minus 1. So, it is a binomial. We know that a binomial and algebraic expressions having two unlike terms is a binomial, and an algebraic expressions having one term is monomial, and an algebraic expressions having 3 unlike terms is trinomial. Okay. So, the answer is choice B. Okay. So, this question was based on addition of algebraic expressions and the basic definition of binomial, monomial, trinomial algebraic expression. These are binomial, trinomial, monomial. These are types of algebraic expressions. Question number 8. What must be subtracted from this to obtain this? Okay, this is a word problem. So it is asking, we have this algebraic expression. What must be subtracted if I consider the algebraic expression that must be subtracted as a box? Then this should be equal to a square plus x square. Now we have to find, if we assume that the algebraic expression that need to be subtracted is e, then from here we know the concept is similar, just like numbers. You know that if x is the unknown, if you are asked what need to be subtracted from a to give b, we assume that if x is need to be subtracted, then we get a minus x equals to b. This implies x equals to a minus b. Similarly, the same concept applies in algebraic expressions as well. So this implies e equals to minus x a square minus x square minus of a square plus a square. Okay, now if we simplify this, this is minus a square minus x square minus a square minus x square. This is minus 2 a square minus 2 x square. So this need to be subtracted. So the answer is choice C. Okay. Question number 9. It's very hot. Okay. Question number 9. Question number 9 says the product of coefficient of x square, y square and z square in a term is given is. The product of coefficient of x square, y square and z square in a term, that is the minus x square, y square, z square is. Okay. So the term given here is minus, this is a term, or you can even consider it as a algebraic expression with single term. So what is the coefficient of x square in this term? The coefficient of x square in this term, if we coefficient, let's say this, if I denote it as a term, let's say term. So coefficient of x square in t equals whatever is remaining if you ignore x square, that is minus y square z square. Similarly, coefficient of y square in t is whatever is remaining in t if you ignore y square, that is minus x square z square. Similarly, coefficient of z square in t equals to whatever is remaining in t if you discard z square, that is minus x square minus x square into y square. So now we have to find the product of this and this. So minus y square z square minus x square z square and minus x square y square. This is the product of the coefficients of x square, y square and z square in t. This is now three terms are there and they are all negative. So the final result will be negative, and x square into x square will be x to the power 4, y square will be y to the power 4, z square into z square will be z to the power 4. The answer is minus x square minus x to the power 4, y to the power 4 and z to the power 4. So the answer is choice D. Okay. Now, so the concept here was coefficient of some factor. I mean, x square is kind of factor because x square is x into x, a kind of factor. The coefficient of some factor in a given term. The concept is this: what is a coefficient of a factor in a given term? It is everything of the term after discarding the factor. Okay, let's do question number 10. What is question number 10? The terms of algebraic expression A are minus x cube comma 2x square y comma y square x comma 3, and the terms of the algebraic expression B are minus 5 y x square minus 2x cube. Then the numerical coefficient of the term having x square as a factor in A minus B is. Then the numerical coefficient of the term having x square as a factor in A minus B. Okay. So first let's find out what is A minus B. What is A minus B? This is, okay, so we know the terms are given. So first we have to get the algebraic expression from the term. If terms are given, we know that what is the algebraic expression. So the terms of A are minus x cube 2x. From the terms we know that the algebraic expression A will be minus x cube plus 2x square y plus y square x plus 3, and B, similarly B will be minus 5 y x square minus 2x cube minus 2x cube. So therefore we have to find A minus B. A minus B equals minus x cube plus 2x square y plus y square x plus 3 and a minus of minus 5x square minus 2x cube. Now I have already discussed in some previous problem how do you find the inverse of an algebraic expression. So we see that the algebraic expressions B we have, it's a basically, so A minus B is nothing but A plus the negative additive inverse of B, that is minus B. So a minus of the algebraic, this is an algebraic expression, this was B, and outside we have a negative. So when we will open this grouping symbol, this parenthesis, the terms of the B will change its sign. So this will become minus x cube plus 2x square y plus y square x plus 3 plus 5y square. If you have to change the sign of 5x square term, it's right now it is negative, so it will become positive, and the negative term minus 2x cube will also be positive, so 2x cube. Now if we combine the like terms having the literal coefficient x cube, it becomes minus 1 plus 2 x cube. This is one like term, and another like term is yx square. So if we combine the like terms having the literal coefficient x square y, it becomes 2 plus 5 x square y, and the unlike terms remaining are y square x plus 3. Okay, so this is x cube plus 7 x square y plus y square x plus 3. So we got this final algebraic expression, and it is asking that then the numerical coefficient of the term having x square as a factor in a minus b. Now a minus b is this. Now in this, which is the term that has x square as a factor? Now the first term is x cube. It doesn't have x square as a factor. Its factor is x cube. The second term is 7x square y. It has a factor x square. It has two factors. It has three factors. In fact, the first one is the 7 is the numerical factor. The second one is the x square. The third one is the y. And the third term, y square x, has two factors, y square and x. And the last term, constant term, it has only one factor, that is 3. So which term has x square as a factor? Obviously this term. Only this term, that is 7x square y, has x square as a factor. Now what is the question asked? Then the numerical coefficient of the term. So the term that has x square as a factor is 7x square y, and this term's numerical coefficient is the constant part as the numerical factor, that is 7. So the answer is B. So I hope this set of problems will help you to get a good practice on all the concepts you have learned from your previous class 6. I was initially planning to discuss all the concepts. I already had my rough notes prepared, but I thought it was so long, it will take a long time, and I did not want to make the video much longer. I don't know how long this video will be anyway. So I hope this video will be beneficial for you, and if it is, then please consider supporting me by subscribing to my channel if you are not yet, and like this video, share this video with your friends, and also please do not forget to press the bell icon so that you will be notified by my future video. Once again, thanks for watching, and until the next video, take care and bye.